morning, students. Today we are going to discuss about the chapter electricity. So as we know that electricity mainly we use in homes, schools and industries. It is very essential for us. And what is electricity? We will discuss in this chapter what is electricity and what are the various uses of electricity. And see here, electricity is actually the flow of charges, flow of electrons. So what do you mean by electrons? Electrons are actually like you studied last year. Electrons are small particles that are revolving around the nucleus of an atom. Electrons are small particles which are revolving around the nucleus of an atom. See, suppose when you consider a metal, see here these are electrons, these are electrons, and these electrons are randomly moving. These electrons are randomly moving here and there. And suppose these are known as free electrons or called conducting electrons. And these electrons they are randomly moving here and there. And suppose in a metallic wire, these electrons constitute the flow of charges. So as we studied the electrons possess a unit negative charge. Electrons possess a unit negative charge. So this flow of charges through a metallic conductor is based on what? The movement of electrons that constitute the flow of charges. So now let us see. So electrons are randomly moving in a metallic conductor. So that may not constitute a flow of electric current. So here what we need to do? We need to use a cell or battery in order to make the electron to move in a particular direction. Suppose if all electrons are moving in one direction, that constitute electric current. Similarly, you can see what do you mean by air current? Air current is the movement of air from one place to another place. And similarly, what do you mean by water current? Water current is what? Yeah, the movement of water from one place to another place. And similarly, here you can see the electrons. If electrons want to move from one place to another place, or one end of the metallic conductor to another end of the metallic conductor, here we need to apply a potential difference across the ends of the conductor, or we need to give some energy, or we need to do some work. Then only these electrons will move from one point to another point. Similarly, you can see. For that we are using what? A cell or a battery that is used for moving these electrons through this metallic wire. See here you can see when you are applying a battery over here, this represents the negative terminal of the battery, and this long lead represents the positive terminal of the battery. See here, the direction of current flow is always from positive terminal to the negative terminal. This is the negative terminal and this is the positive terminal. See what is happening. See here you can see the electrons, but the direction of flow of electrons is actually from the negative terminal to the positive terminal. See when we apply potential difference using a cell or battery, the electrons will start moving from one end to another end, basically from negative terminal to the positive terminal. But the direction of electric current, so at the time when we this particular electricity when it was discovered, so electrons were not known at that time. So scientists believed that, or people thought that the electric current is actually the flow of positive charge. So they thought like that it is a flow of positive charge. So after the discovery of electrons, we know that electrons are negatively charged. Electrons are negatively charged. So we keep the concept same. The direction of flow of current is from positive terminal to the negative terminal, but the direction of flow of electrons are from negative terminal to the positive terminal. So actually we know that positive charge that is present in protons. Protons are residing in the nucleus, so they are not able to go. But here electrons are present in the outermost shell. So these electrons can flow from one place to another place. So actually what is electric current? So the direction of flow of electric current, or the direction of electric current is from positive terminal to the negative terminal. And the flow of electron is from negative terminal to the positive terminal. Always remember that the flow of electron is always from negative terminal to the positive terminal. But the direction of electric current we are taking not to respect the previous notion. Electric current is from positive terminal to the negative terminal. Okay. Now let us see what is an electric circuit. So here I have drawn an electric circuit. So which represents the long lead represents the positive terminal of the battery, the short one negative terminal. See, the current is flowing from positive terminal. So this represents a bulb, and this is ammeter. An ammeter just got positive terminal and negative terminal. So the ammeter is used for measuring. It is used for measuring electric current. How much electric current is flowing through this circuit? Clear. So which is an instrument that is used for measuring electric current in the circuit. And see, here you can see the current. And this device, it has got positive terminal and negative terminal, and this positive terminal is always connected to the positive terminal of the battery. The negative terminal is connected to the negative terminal of the battery, and it is connected using a switch. And what do you mean by switch? Switch has got so it makes a conducting link between bulb and the cell. So here you can see we don't use it for either switching on or keeping the circuit turned off. So that's a function of an electric switch. Very keep in mind. What is ammeter? Ammeter, it's an instrument. It's an instrument used for measuring electric current. How much electric current is flowing through the circuit? See, using electric, say, cell or battery. So when electric current or electrons flow in the circuit from negative terminal to the positive terminal, as a result of that, the electric bulb start glowing. And similarly, you can see. So ammeter, always remember, ammeter is always connected in series with the circuit. So just this is ammeter is always connected in series with the circuit. Now we come back to this. So now we can define what do you mean by electric current. We can define electric current as what? Electric current is defined as the rate of flow charges. Electric current can be defined as the rate of flow charges. See, here we already studied the electrons. Electrons process unit negative charge. And protons and unit positive charge. The positive and negative charges. The positive and negative there are two types of charges, positive and negative charge. See, what do you mean by electric current? Electric current is defined as the rate of flow charges. See here, especially here we are considering as the charge carriers. The charge carriers are electrons. Or actually, electrons constitute the flow of electric current. So what we define as electric current I. Electric current is represented by the symbol I, and it is equal to the rate of flow of charges Q. Here Q represents the charges, Q represents the charge, and And 1 ampere, what do you see? The SI unit of electric current. The SI unit of electric current is ampere. This is a unit in which we measure electric current. What do you mean by 1 ampere? 1 ampere, we can define 1 ampere as 1 coulomb upon 1 second. The SI unit of electric charge is coulomb. And the SI unit of, so what do you mean by 1 coulomb? 1 coulomb is the charge present in nearly 6 into 10 raised to 18 electrons. And there is one equation that is called Q is equal to N into E. That is as per the quantization of charges. So we already studied that electron, each electron possesses a charge of 1.6 into 10 raised to minus 19 coulomb. Okay, so that we can calculate the number of electrons that would require in order to constitute 1 coulomb of charge. We already said that 1 coulomb is the charge present in nearly 6 into 10 raised to 18 electrons. So approximately, it's an approximate value. In order to constitute a charge of 1 coulomb, it is approximately the charge present in nearly 6 into 10 raised to 18 electrons. And see, using this equation we can calculate that. See what is N is equal to Q upon E. Suppose say if Q is 1 coulomb, say Q is 1 coulomb and N is the number of electrons that are required to constitute an electric charge of 1 coulomb. See, then Q divided by E. What is E? E is the charge on 1 electron. E is the charge on 1 electron, that is what E is equal to 1.6 into 10 raised to minus 90 coulomb. So let us, so when you take this division, 1 divided by 1.6 into 10 raised to minus 90, that will be equal to, when you do the calculation, you can see, or you can see 10 divided by 1.6. 10 divided by 1.6, so that will be, you will get approximately 6.25 into 10 raised to 18 electrons. Okay, so this much number of electrons are required to constitute 1 coulomb of charge. Say, and suppose if 1 coulomb, see, if this much number of electrons are flowing in 1 second, if 6.25 into 10 raised to 18 electrons are flowing per second, that will constitute an electric charge of electric current of 1 ampere. Okay. So now let us look at a numerical, that is I is equal to Q upon T. Using this equation, what is I? I is current. Q is what? Q is electric charge and T is time. So what is electric current? Electric current we can define as the rate of flow of charges, that is Q divided by T. Q represents charge and T represents time. See, suppose we have got in the question, see the current is given, I is equal to 0.5 ampere and T is equal to 10 minutes. This question is there in your textbook. And so suppose here time we need to convert into seconds. 10 into 60, that is what? 600 seconds. 10 minutes you need to convert first into seconds. So what is, here we need to calculate Q. What is Q here? Q we can rearrange, while rearranging this equation we will get Q is equal to I into T. So that is 0.5 into 0.5 ampere into time we have converted into seconds, 0.5 into 600. So you will get Q is equal to 300 coulomb. And similarly, do this particular question. So if current I is equal to 10 ampere and T is equal to 30 minutes, time is 30 minutes, you need to convert into seconds. So you calculate Q. Okay, I hope you understood this lesson, this particular part. If you have any doubt, you just ask me a doubt. Okay. Thank you.